So let's say you have a coordinate plane right here, x and y. Yes?
Yeah.
Let's say you have a little triangle here. And we're going to be told, each of these have coordinates, x and y coordinates, yes? So we're told, okay, so you should move each of the x coordinates 4 places to the right and 2 places down. So that would be there, that would be about there, and I don't know, I'm not doing it quite right here, but we will, don't worry. So I moved them the same distance, whatever the rule told me to move each point. And so that means I've translated that figure. Have I changed its size at all? Did I change its shape at all? That's a translation. You're just sliding it from one spot to another basically on the graph. That's what a translation is. Okay? We don't, but we will. We will see that. All right, so right now, with that in mind, I want you to think about this one, and this one, and this one, and see if you can do it. Just think about it and give it a try. And then here, you're just using the distance formula. Here, you had to translate using the rule. That's called the rule. Here's my new points, and then I found the distance between those two. Uh-oh, yes?
For the second one, you did the square root of 16 plus the square root of 9 equals 25. You would have the square root.
Oh, it would be 5. Yeah, thank you. 5. There you go. Thank you. All right. So that's that. Let's talk a little bit more about this. Some definitions, a whole bunch of more words that you're going to get. Okay, can I move on? All right. All right, an image and a pre-image. So an image is a figure after a transformation. Now this is a different word than translation. I get that. A translation is one of a few different transformations you can do because it moves a shape or a pre-image to an image. There's also a reflection. There's also a rotation. We're going to get to all those later. Today we're just doing translation, which is a transformation. Transforming, it kind of makes sense, right? You're transforming something. And one way to do that is with a translation. Pre-image is the original figure before a transformation. So up here, this was my pre-image. You don't necessarily need to draw that. And this is my image after I transformed it. Pre-image, image. Kind of makes sense. All right, isometry is a transformation that preserves the length and angle measure. Yes, it rhymes with geometry. Isometry. Also called the congruence transformation because nothing changes but the place it's sitting. The size and the shape don't change. Isometric is another word. Have you heard that before? Isometric. It's also called the congruence transformation. All right, a vector. That's something else you're going to learn today. It's another way to describe a translation. A quantity that has both direction. Right on.
Yes!
Is that from science? Did you learn it in science?
Despicable Me.
Oh, it is? Oh my gosh, I should have showed a piece of it. She's so proud. That's so funny. So, I gotta make a note to look that up and show it as part of the YouTube. It's written as an ordered pair. That is so funny. Okay, now ladies and gentlemen. It's written as an ordered pair, but instead of using parentheses, you use these like sideway V's. Sideway V's for vector. That's kind of how you do it. Okay?
Oh my gosh. I love this.
It is the starting point. The initial point is the starting point of the vector.
Yeah, you should look at mine. Some of these are just like
Yeah, terminal point, it is the ending point.
The terminal.
Okay, moving on. Component form. The component form of a vertex combines the vertical. This will all make sense shortly, I promise. The vertical and the horizontal components. Now, does anybody know what a vertex looks like, kind of, on a coordinate plane?
It's where is it?
They don't show you that in the movie, huh? Okay.
It looks like this guy named.
So this vertex on this graph would start, let's say it starts here at the pre-image, and it's just like a ray that goes to the image. That's a vertex. That's how it's shown on a graph. Okay, and it talks about the horizontal movement and the vertical movement, and we're going to look at that. So it's actually written like a ray. So write this right here. Let's say we have vector FG, and this is its component. So vector FG, and it's a 5, 3, and I'll show you what that means. So the horizontal component is how many units right or left. So in vector FG, this is your horizontal component, the one that shows you the left and right movement. This tells me that I either go right 5 or left 5. What do you think? Right 5, because it's a positive 5. Okay? And then the vertical components is how many units up or down. So you can guess that that would be the one that has the in the Y position. Correct. That is the vertical component right there. Tells you to go up 3. So this translation would actually be right 5, up 3. Easy enough, right? All right. So this stuff has to do with vectors. It's just another way of writing a translation. Right now, they're not talking about the vector. They're just having us translate something with a rule. Okay, so we're not going to do the whole V thing, the little thing like that. It says graph the quadrilateral KLMN with vertices, these vertices right here. Find the image of each vertex after the translation of x minus 4 on y plus 2. Then graph the image using prime notation. What I want you to do first is I want you to graph these 4 points and connect them. This stands for K prime is how you say it. K prime. You put that little thingy next to it. Tick mark. Means it's the image. That's all it means. It's just what it's called, K prime. Okay? And what you do is it tells you that we have to subtract 4 from the x-coordinate and add 2 to the y-coordinate. And if you saw that written out, it would look like this. The original x-coordinate was 0. I'm subtracting 4. The original y-coordinate was negative 2, and I'm adding 2. So my K prime would be, what's 0 minus 4? And 0. Okay? That's just written out longhand. You don't have to do that every time. I'm just doing it to show you guys. So then we can do the same thing to L. We would do 4 minus 4 for your x-coordinate and 3 plus 2 for your y-coordinate. And you would get 0, 5 for L prime after the translation. Now let's do it without writing it out. For M, we'd have 5, and we're going to take away 4. So what's my x-coordinate? 1. And then we have 2, add 2, and my y-coordinate would be 4. And then N, the same thing. 6 take away 4 is 2. Negative 1, add 2 is 1. Okay? So now you're going to graph K prime, L prime, M prime, and N prime. And you should get the exact same shape, just in a different spot on your graph. So give it a try. And then label them KLM prime. I did something wrong. Oh, I see, I did M, original M wrong. M should be here, yeah. So you really should get, you should get the same looking kind of thing. So this is K prime, and then label it L prime, M prime, N prime. And you just translated it.
My first translation.
Mine's a mess. Mine's a hot mess, but that's okay. It looked better earlier. So that's doable, right? Not too bad. Okay, turn it over so we can get to vectors. Rule based off the picture. How do we know which one's the image and which one's the pre-image? How do we know?
By the little markers.
Yeah, this is after the translation right here, isn't it? So what I would suggest you do is just pick one point and count the X and Y movement. So then you're going to write the rule. It's going to be like an ordered pair. So let's look at F here. We'll start with F. So I'm going to go over 1, 2, 3, 4, 5, correct? Over 5. And then what did I do? 1, 2, 3, up 3. Oh, that's,
I think 2X.
it does look like it, isn't it?
That's an E.
That's an E. Okay, that's an E. Yeah, so I did E.
So 4.
I'm having all sorts of technical issues right now. So you would say, all right, what am I doing to my X coordinate to go from my pre-image to my image? Adding 5, correct? 5 to the right.
Isn't the top one E?
And then the Y coordinate, what am I doing to the Y coordinate? Going up 3. So that's your rule. You would do add 5, up 3 for every X and Y coordinate to get your image. Not too bad, right? All right, let's do the vector here. Name the vector and write its component form. So it's a ray. And how would we name this ray?
Ray M.
Be careful. You start from its end point. Yeah, so it's going to be ray LM. And then I got to write its components inside there. So I'm going to say, all right, I went over 1, 2, 3, 4, 5, 6, 7 to the left. So that's -7. And then I went up 1, 2, 3. So you don't use the X and the Y when you're writing the vector. You just put the numbers in there. So it's -7, 3. All right, this is ray no. N-O.
No.
Okay. Its components, let's take a look. Do we go anywhere left or right? So we put a 0. Left to right, there's no right, left to right movement. 1, 2, 3, 4, 5, 6, up. There we go. Vector, no. No vector. Whatever. Okay. So here we go. Here's one more. The vertices triangle DEF are -2, 0, -1, 3, and 2, -1. Graph those 3. That's your pre-image. So go ahead and graph those. Nope. Okay, now you have to translate it using the vectors. So this means to do what? What's this telling me to do?
Add 2 to each.
Yeah, it's really x plus 2, isn't it? And this is really, but you don't even have to write it. You can just count. From each point, you just count. So I'm going to start at E here. I'm going to go over 2, and down 3. 1, 2, 1, 2, 3. There's my E prime. Then I do it for F. Over 2, down 3. There's my F prime. And then you do it for D. Over 2, down 3, D prime. And then you've translated that triangle. Cool, huh? Nifty. Okay, let's do one more thing here. Ingrid hit a golf ball from the tee toward the hole. Here's the tee. After she hit the ball, it got as far as point Y, this is Y, when a gust of wind blew it to point X.
Whoosh.
But you never thought of it like this, did you? All right. Write a component form of ray Ty. So from here to here, we need to write a component form. So we're going to write the vector. So it went from 0 to what? Yep, and that's positive, 220. And it went up 85. So there you go. Over 220, up 85. Then it says, write the component form of yx. So it's from here to here now. So I'm going to do this. So how much did my x-coordinate change? 20 to the right, didn't it? It got bigger, so it's 20. And it went down on the y by 35. 20 negative 35. Then it says, write the component form of the vector that describes the straight line path from point X, where the ball landed, to hole H. So we're going to go up to here now.
This is crazy.
So we went from 240 to 250. So X only changed by how much? And then Y went up by what? Boom. That is it. No problem, right?
Easy.